You are descending into the deepest abyss on Earth, a realm of crushing darkness where pressure exceeds 1,100 atmospheres, more than 1,100 times the pressure at the surface, equivalent to roughly 1.1 tons per square centimeter, about 15,750 psi, or 1,086 to 1,113 bar. If a human body were exposed to this pressure without any protection, it would be crushed almost instantly. Every air-filled space in the body, lungs, sinuses, middle ear, would collapse in a fraction of a second. The rib cage would shatter, and internal organs would be compressed flat, as if thousands of elephants were standing on you at once. Here, in the Challenger Deep of the Mariana Trench, only a handful of humans have ever arrived, pioneers who dared the plunge into a place that defies survival. Compare this abyss to the world's tallest mountain. Mount Everest rises 8,849 meters above sea level, a monument of rock and ice conquered by thousands. Yet the Challenger Deep plunges to approximately 10,935 meters, more than 2 kilometers deeper than Everest is high, creating a vertical distance from the ocean's surface to its floor that dwarfs any terrestrial peak. This is no mere hole in the seafloor. It is a tectonic scar born from the subduction of the Pacific Plate beneath the Mariana Plate, a geological process stretching back millions of years that continues to reshape the planet's crust even now.
The first humans to reach this frontier arrived in 1960 aboard the bathyscaphe Trieste. Swiss engineer Jacques Piccard and U.S. Navy Lieutenant Don Walsh endured a nearly 5-hour descent, touching bottom at roughly 10,908 meters in the Western Pool. Their vessel featured a steel pressure sphere with walls 12.7 centimeters thick. Even so, while passing around 9,000 meters, one of the outer plexiglass window panes suddenly cracked with a loud, explosive bang, violently shaking the entire craft. A terrifying reminder of just how immense the pressure is at these depths. More than half a century passed before filmmaker and explorer James Cameron made the next solo descent in 2012 with the Deep-Sea Challenger, reaching the eastern pool at nearly 10,908 meters and spending hours documenting the alien landscape. Then, beginning in 2019, the Triton-built DSV Limiting Factor, piloted by Victor Vescovo and others, transformed the impossible into the repeatable. Multiple missions through 2025 and beyond have now carried explorers to these depths dozens of times, yielding new samples, observations, and even the discovery of plastic debris alongside previously unknown life forms. Why does the most extreme environment on our planet birth creatures that appear nightmarish, yet represent masterpieces of evolutionary engineering? The submersible slips past the sunlit epipelagic realm and into the mesopelagic twilight zone, 200 meters down, where faint blue light still filters from above like a dying echo. Here, in this mid-water layer, the world begins to fade. Descending further, the bathypelagic midnight zone engulfs the vessel at 1,000 meters. Sunlight vanishes forever. From this depth to the very bottom of the trenches, perpetual darkness rules. An eternal night unbroken for millions of years. Pressure builds relentlessly. At the Challenger Deep, it reaches more than 1,100 atmospheres, equivalent to 8 tons crushing down on every square centimeter of surface. The weight of 3 or 4 fully loaded SUVs stacked upon a single coin. This force would pulverize an unprotected human body in roughly 2 seconds, collapsing lungs, liquefying soft tissues, and grinding bones into fragments as water itself becomes a weapon of compression.
Yet the submersible's hull holds a fragile bubble of engineered defiance against the abyss.
Temperatures plummet to a near freezing 1 to 4 degrees Celsius and remain locked there, indifferent to season or storm above. In this cold, oxygen-starved realm, food is almost non-existent. No plants grow, no sunlight fuels photosynthesis. Life here survives on a slow, ceaseless rain of marine snow, tiny flakes of dead plankton, fecal pellets, and organic debris drifting down from distant surface layers, the biological pump that connects the sunlit world to the void below. Every particle represents a rare gift in a desert of scarcity. The descent continues through the abyssopelagic depths and finally crosses 6,000 meters into the hadal zone, the realm of the trenches, named after Hades himself. Here, in the Challenger Deep, the pressure, darkness, and cold combine into one of the most extreme environments on the planet. Yet even as these conditions seem engineered for sterility, life persists. It does not merely endure, it has evolved along the most extraordinary, almost insane pathways imaginable over countless generations of natural selection. These are not random survivors. They are masterpieces of adaptation forged in the crucible of the deep. The submersible's lights pierce the hadal darkness, revealing creatures that seem forged from the very pressure that should destroy them. First appears the hadal snailfish, a ghostly apparition drifting near the trench floor. Its body is nearly 90% water and fat, a gelatinous form that flows with the current rather than fights it. Bones thin as rice paper flex under the load. The skull remains incompletely closed, a deliberate evolutionary gap that equalizes internal and external forces, preventing catastrophic implosion. No rigid armor here. Instead, the fish has shed heavy mineralization in key genes, trading strength for pliancy in a realm where every cubic centimeter bears the weight of 8 tons. Slow-motion footage captures its languid glide, fins undulating with minimal effort. In this environment, energy conservation is survival. High-pressure resistant proteins and elevated levels of stabilizing compounds like trimethylamine N oxide keep cellular machinery functioning where ordinary enzymes would fail. These piezophilic adaptations allow metabolic enzymes, such as lactate dehydrogenase, to operate more efficiently under crushing force than at the surface. The snailfish does not merely tolerate the abyss, it has been sculpted by it over millions of years of selection.
Nearby, another phantom emerges, the Dumbo octopus, Grimpoteuthis. Its ear-like fins flap in slow, deliberate strokes, propelling the creature like a living balloon through the water column. The entire body is soft, gelatinous, lacking any gas-filled spaces that would collapse under pressure. Webbed arms trail beneath, ready to envelop scarce prey or carrion. In the hadal zone, where every movement costs precious calories, this fin-driven flight conserves energy that jet propulsion would squander. Then came the hadal amphipods, super scavengers of the trench. Their bodies swell to exaggerated size, translucent exoskeletons revealing internal organs like living glass. These crustaceans detect the faintest chemical trails of falling marine snow or rare food falls, swarming with chemosensory precision. Enlarged, pressure-tolerant forms allow them to dominate the scavenging niche, their piezophile proteins and flexible physiology thriving where surface dwellers will be crushed in seconds.
No gas bladders exist in these beings. Evolution has eliminated compressible voids, filling tissues with incompressible fluids and specialized lipids that maintain membrane fluidity under extreme compression. Yet this perfection is one-sided. Bring these creatures to the surface, and the equilibrium shatters. Without the crushing weight that shapes every molecule, their gelatinous bodies lose structural integrity. Proteins destabilize, tissues rupture, and in moments, they dissolve into formless slime, a final testament to how completely they belong to the deep. Here, in the hadal realm, life has not been compromised. It has specialized to the point of fragility at 1 atmosphere, revealing the exquisite, unforgiving precision of evolution under pressure. The submersible's beams carve through absolute darkness, a void so complete that beyond 1,000 meters, no trace of sunlight has ever reached. In this eternal night of the hadal zone, vision as we know it becomes useless. Yet evolution has answered with eyes and lights that defy the black. Enter the barrel-eye fish, Macropina microstoma, a creature whose transparent, fluid-filled head dome shields tubular eyes like living periscopes. These green-lensed tubes point upward by default, scanning for the faint silhouettes of prey or scavengers outlined against any stray bioluminescent glow from above. When opportunity strikes, the eyes rotate forward within their protective shield, granting binocular focus on a meal. This 360-degree adaptability, housed behind a clear skull that also shields sensitive tissues from stinging siphonophores, represents a precise evolutionary refinement honed over millions of years in the deep. Nearby, the stoplight loosejaw hunts with a secret weapon. Beneath each eye, photophores emit red bioluminescence, a wavelength invisible to nearly all other deep-sea inhabitants who lack the pigments to detect it. To most residents of the abyss, this predator remains cloaked in perfect stealth, its red flashlight illuminating prey that cannot see the glow coming. The loose jaw's massive, unhinged jaws then snap shut in a trap-like strike, exploiting a private spectrum that evolution has granted it alone. But no creature embodies the madness and genius of hadal survival more completely than the anglerfish. Females drift like nightmares given form, oversized heads, needle-sharp fangs, and a slender elysium extending forward like a fishing rod, tipped with the esca, a bioluminescent lure swollen with symbiotic bacteria. The glowing bait pulses in the dark, drawing curious victims close enough for the angler's lightning strike. These bacteria, acquired from the environment rather than inherited, produce a cold blue light through luciferin-luciferase reactions, turning scarcity into opportunity. Even more extraordinary is their reproduction. In the vast emptiness where encounters are rare, dwarfed males have evolved into parasitic seekers. Upon locating a female, guided perhaps by pheromones or faint light, he bites into her flesh. In the most extreme ceratoid species, his body fuses permanently. Tissues merge, immune barriers dissolve through evolutionary loss of key rejection mechanisms, and circulatory systems unite. The male shrinks, his organs atrophy, and he transforms into little more than a living sperm sac attached to her side, sometimes multiple males on one female. This creepiest yet smartest strategy ensures constant fertilization in a realm where finding another mate may never happen again. It is sexual parasitism refined by natural selection into a grotesque but ruthlessly efficient partnership. Phantom jellyfish glide through the same waters like crimson ghosts. Their massive bells trail ribbon-like oral arms that can span 10 meters, pulsing with bioluminescent displays that startle predators, or perhaps coordinate with unseen kin. Across the hadal community, bioluminescence dominates. Roughly 70 to 90% of organisms here produce their own light. Many employ counter-illumination, matching the faint downwelling glow from far above on their undersides to erase their silhouettes from below, turning potential prey into invisible phantoms against the abyss. In this realm of total darkness, light is not decoration. It is language, weapon, lure, and cloak. Evolution has turned the absence of sun into a symphony of living stars, each species a masterpiece sculpted by pressure, scarcity, and endless night.
Nearby, the fangtooth fish waits in ambush. Its dagger-like teeth are the longest relative to body size of any known fish, so enormous that specialized sockets in the roof of its mouth allow the jaws to close without impaling its own brain. These fangs function as a living rat trap, impaling slippery squid or fish that wander too close. In the sparse hadal waters, such weaponry ensures that no encounter is wasted. The vampire squid, Vampiroteuthis infernalis, deploys an even more elegant defense against both predators and scarcity. It is no true squid, but a living relic, cloaked in a webbed mantle that it can invert like a spiny cape, exposing rows of sharp projections while flashing bioluminescent photophores. When threatened, it ejects a cloud of sticky, glowing mucus from the tips of its tentacles, a luminous barrage that can burn for up to 10 minutes, dazzling attackers and buying time to vanish into the dark. Between rare meals, it drifts with minimal effort, its low metabolism physiology tuned to the long waits between falling particles.
When a whale carcass finally reaches the trench floor, a rare but massive whale fall, the ecosystem explodes into opportunistic frenzy. Here, zombie worms of the genus Ocedax colonize the bones within days. Lacking mouths or digestive tracts, these females extend root-like structures that secrete acid to bore into the skeleton. Symbiotic bacteria inside the roots break down the lipids locked within the bone, feeding the worm in a partnership refined across millions of years. Dwarf males live inside the females as little more than sperm factories, ensuring reproduction in the vast emptiness. One carcass can sustain an entire localized community for decades before the last nutrients vanish. Across these depths, deep-sea gigantism reigns. Giant isopods grow to the size of dinner plates, their armored bodies capable of surviving years without food by gorging when a meal arrives. The colossal squid, with eyes the size of dinner plates and tentacles that can exceed 10 meters, patrols these waters as an apex predator. Larger size confers critical advantages: greater energy storage in lipid reserves, more efficient metabolism per unit mass, and the ability to range farther across the food-poor seafloor. Cold temperatures slow growth and extend lifespans, while higher dissolved oxygen in deep waters supports the metabolic demands of larger tissues. In a desert of scarcity, being big is not excess, it is the ultimate economy. These creatures do not merely survive the hadal starvation, they have weaponized it, turning every rare windfall into a banquet and every lean decade into another generation of refined monstrosity. Here, hunger itself has become the sculptor of life.
The lights of the submersible dim as it begins its long ascent, yet the questions linger in the crushing dark below. Even today,
humanity has visually observed less than 1/1000th of 1% of the deep sea floor, roughly the area of a small state like Rhode Island across the entire global abyss. We have mapped only about 29% of the ocean floor with modern high-resolution tools, leaving vast realms, including most of the hadal trenches, still shrouded in mystery. The Challenger Deep itself remains a frontier where every new descent yields surprises. Yet our shadow already reaches these depths. Plastic debris litters the trench floor. Single-use bags, bottles, and fragments funneled downward by currents and the trench's natural trap-like topography. In 1998, a Japanese ROV captured the first images of a plastic bag resting nearly 11 kilometers down. More recent expeditions have documented widespread microplastics and macro waste, some of it decades old. Farther afield, proposals for deep-sea mining near the Mariana region threaten to scar the seafloor with sediment plumes, noise, and habitat destruction that could persist for centuries, starving fragile communities already tuned to extreme scarcity.
Still, discovery continues. Between 2020 and 2025, scientists have described new species of snailfish thriving in abyssal and hadal realms, including the strikingly pink bumpy snailfish and its relatives, each revealing fresh adaptations to pressure and hunger. Mysterious sounds like the biotwang, a complex, otherworldly call first recorded near the Mariana Trench, were finally traced in recent years to Bride's whales, proving that even the surface world's giants reach their voices into the deep. These gelatinous ghosts and luminous hunters are not monsters. They are living proof that life can conquer any hell our planet creates, masterpieces of evolutionary ingenuity refined across millions of years. Yet if we destroy them before we truly understand their secrets, we risk erasing the most extraordinary chapter in Earth's book of evolution, a chapter still being written in darkness. The abyss is not a distant alien world. It is part of our home. Support the missions that illuminate it. Protect what little we have begun to see. Because the deepest sea is also our sea, and its future rests in our hands.